Greetings, inhabitants of planet Earth, and welcome to Basic Chemistry Explained with Alexa Lolo. Today we're going to talk about the periodic law. When the elements are arranged into the periodic table, certain patterns occur that help to predict an element's properties just by knowing its location on the periodic table. Let's start with the atomic radius. When you put two atoms together, identical atoms, let's say two hydrogens, and you want to find out the atomic radius, you would take the distance between the two nuclei of these atoms and divide it by 2. Let's say you have two atoms of an equal amount of protons, and you want to find out which one has a bigger atomic radius and which one has a smaller atomic radius. Well, if you think about it, the one with 5 protons must be stronger than the one with 2 protons, because it has more positive particles. And as you know, positive particles attract negative electrons. We can say that the one with more protons is stronger. And because it's stronger, it can hold the electrons closer to the nucleus. Now, the one that has less protons actually can't hold them as well, so the atomic radius is bigger. So let's write that down. Stronger nucleus, which means more protons, equals a smaller atomic radius. It is also well known that chlorine has more energy levels than hydrogen. That means that the valence electrons of chlorine are further away from its nucleus than the electrons of hydrogen. And so we can conclude that a higher energy level equals a larger atomic radius. Now, looking at the periodic table, we know that going to the right, we increase the number of protons, and going down, we also increase the number of protons. We also know that going down increases our energy level. So, you realize that higher energy level means larger atomic radius and more protons means smaller. So these two conflict. So let's figure out what's happening here. So let's imagine an atom of chlorine. It has some electrons in the first and second energy level that are shielding its valence electrons away from the nucleus. They are like a barrier between the valence and the nucleus. And you know that negative and negative charges repel each other, which means that more electrons means valence electrons are less attracted to the nucleus because of the repulsion of the electrons that are not valence. They are in between, they're shielding electrons. Let's say you have a positive nucleus and a negative electron, and they are attracted to each other. And then you also happen to have an electron in a higher energy level. This electron is also attracted to the positive nucleus, but it's being repelled by the negative electron that is between it and the nucleus, which means it's going to be pushed slightly further away than it would if there would be no electron in between it and the nucleus. Makes sense, right? It still is orbiting the nucleus because it's still attracted to it, but it's less attracted because there are also negative particles that repel it. So that's what we call shielding electrons. When you don't have shielding electrons, then the electron is attracted to the nucleus directly and is much closer to it. So now let's try to make sense of all of this information. Let's write down more electrons equals valence electrons less attracted to the nucleus. And let's look what it gives us for the trend on our periodic table. Higher energy level going down increases, and more protons going to the right. So that means that the atomic radius trend going down increases and going to the left increases. The bottom left corner is the biggest atomic radius, and the top right corner of the periodic table is the smallest atomic radius. Well, we know that non-valence electrons are shielding the valence electron from the nucleus. We also know that more electrons generally means that the electrons are going to push each other apart. They're going to be further away from each other, which means that the atomic radius will be bigger. We also know that when we have less electrons push each other away and they need less space. So we have a smaller atomic radius. Analyzing this information, will make us conclude that cations that lose electrons have a smaller atomic radius, and anions, which gain electrons, have a larger atomic radius than the neutral atom. It actually makes a lot of sense if you think about it. So if you are not following, you can just stop the video and think about it for a bit. We are on to ionization energy at this point. Ionization energy tells us how much energy is required to remove an electron from the atom, or to make it a cation. Well, what's the trend for it, you say? On the left side of the periodic table, we have all the elements that want to lose their electrons in order to be stable. And on the right side, we have all the atoms that want to gain to fill their electron shells. Ionization energy is the energy required to remove an electron. With the atoms that want to lose their electrons, it's easy for them. And the atoms that don't want to lose, they want to gain electrons, it's harder to do for them. Which means it takes less energy to remove an electron from the atoms that want to do it, and more energy from the atoms that are resistant to it. Ionization energy increases going to the right, and ionization energy increases going up. Well, what do you mean it's increasing going up? Well, remember that more electrons means valence electrons are less attracted to the nucleus. Going up, it increases because the electrons are more attracted to the nucleus, and that's why they're held better in place. Hydrogen holds their electrons much closer to its nucleus than francium would. Francium has like the electrons all over the place, not close to it at all, because it has a lot of shielding electrons. Well, hydrogen doesn't have any shielding electrons, so its electron is really close to its proton. Here's a point I made verbally, but now it's written down, if it's helpful. Anyways, electron affinity. Electron affinity is the energy released when an electron is added to a neutral atom. Electronegativity is basically a measure of how much an atom wants an electron. So let's say we have two atoms, one of sodium and one of chlorine. Sodium has 1 valence electron and chlorine has 7. In order to be stable, sodium has to lose its electron and chlorine has to gain an electron. Which means if we have an electron battle, we have 1 electron and these two atoms, chlorine is more likely to get that electron because it wants it. And on the other hand, sodium does not want another electron, which means it will not get it. So it has a low electronegativity. Electronegativity tells us how likely an atom is going to take an electron in a bond. Ionic and polar bonds form between atoms that have different electronegativities. Let's put a scale of the difference in electronegativity in a bond. So let's say the difference of electronegativity between the two bonding atoms is very low. We can say that the bond is probably going to be covalent because the atoms have low electronegativity difference. Now, if they have a slightly bigger difference in electronegativity, then the two atoms are going to form a polar bond because one of them is going to be more likely to have the electron. Now, if they have a drastically different electronegativity between each other, the bond is going to be ionic because the electron is going to get transferred completely. Electronegativity is very often confused with the term electron affinity. The difference here is that the electronegativity tells you how much it wants an electron, and electron affinity tells us how much energy is needed to give it an electron. Characteristics. Alkali metals are reactive, not found freely in nature, low density, and have low melting points. Alkaline earth metals are shiny, reactive, form cations with +2 charge, are low density, low boiling points, and melting points. The transition metals have high melting points and high boiling points. They are hard and high density, and they conduct electricity. Metalloids are semiconductors, which means they conduct electricity under some certain conditions. They share some properties of metals and some properties of nonmetals. Nonmetals are brittle, have high ionization energy, low electronegativity, and do not conduct heat or electricity. That's it for today. See you in another episode.